Okay, let's get back at this differential equation stuff. Okay, once again we have a dy dx, right? That's our standard differential equation look-alike contest winner. And we have an equation over here that has a plus in it. Okay, so our one rule is that we can't do separation of variables with addition. We can only do it with multiplication. So how do we change addition into multiplication? It is our mathematical F word, and that is by factoring. Okay, anytime we change addition by factoring means multipliers, right? Factors. What are the factors of 7? Well, 7 and 1, because those multiply together. So whenever we're factoring, we're trying to change this into a multiplication problem. So what do 4x cubed y and 12y cubed have as common multipliers? What can I factor out?
4x cubed.
Of 4x cubed. Okay, I can factor out a 4x cubed. That leaves me with a y and a plus and a 3, I believe. Y plus 3. Right, the 4x divides 4x. 12 divided by 4 is 3. And I have a y. So now I have multiplication. It's 4x cubed times y plus 3. So I can do my separation of variables by dividing both sides by y plus 3. So what will come in the denominator? And multiplying both sides by dx. That will come up here behind 4x cubed. Okay, our next step in solving this is to integrate, right? Take the antiderivative. So we integrate the left and we integrate the right. Here we have our 1 over a linear equation. What does 1 over a linear anti-derive to? A natural log. Excellent. Anti derives to a natural log. 1 over a linear. Now, if there were a coefficient in front of y, then it would be 1 over that coefficient out here. Right? But since there's not a coefficient of y, we don't have to worry about that part. Just remember though, if there is. And on the right side, what's the antiderivative of 4x cubed? 4x to the 4th over 4, which just simplifies to x to the 4th, plus c. Now we use our initial condition. We have an x value of 1, and we have a y value of minus 5. And 1. Well, 1 to the 4th is just 1. That's pretty simple. That's a pretty easy one. But this other side is going to be some type of a something else. So the natural log of negative 5 plus 3 is the natural log of negative 2, which in absolute value is the natural log of positive 2. Minus 1 equals c. Okay, now we're going to use our natural log of 2 minus 1 and come back up in here to c. So we have this wonderful equation that we need to now get rid of the natural log, and we do that by exponentiating. So both of these become powers of a base of e. Okay, and we do that, of course, because the natural log of e, right, cancels itself out. Those ones are inverse operations. And then this, we can raise e to each of these powers. Each of these powers. So this is e to the x squared times e to the natural log of 2 times e to the negative 1. Okay, so it's the negative 1 power. So we don't just get rid of that minus. It becomes an e to the negative 1 power. So when we simplify this, right, these ones, e to the natural log cancels out, and we get a 2 as an exponent. Okay, I can rewrite e to the negative first power as 1 over e. So that's going to be 2 over e times e to the x squared power. Okay, that's what the right side will simplify to. And then our last step is to minus 3. So that comes after and that becomes our final equation. 2 over e times e to the x to the fourth minus 3. Okay, -2 is -2, and we have this differential equation. So we're going to start, this is going to be quick. So y dy equals 4x dx. Right, that's what happens when we separate our variables. We get multiplication on both sides. Right, no division. So the antiderivative of y is y squared over 2. The antiderivative of 4x squared is, 4x is 2x squared plus c. Now let's plug in our initial conditions. X is -2 and y is -2. Okay, -2 for both of them. Gives me a 4. This is a positive 4. 4 divided by 2 is 2. This is a positive 4. 4 times 2 is 8. So C is -6. So that gives me the equation y squared over 2 equals 2x squared minus 6. Now we have to solve this for y. Okay, so we multiply everything by 2 to get rid of this denominator. Y squared equals 4x squared minus 12, and then we take the square roots. Okay, now here's the deal. Are you ready for the deal? 4x squared minus 12. Now, look at your initial condition. When x is negative, y is also negative. So how do we get the negative part of a square root? Square roots are positive. The square root of a number is a positive number. You cannot take the square root of a negative. So how do we get a negative y value if you can only take a positive? If you can, square roots are always positive or, of course, imaginary. How do we get a negative? Plus or minus. Whenever we take a square root, we get the positive one and the negative one. So if we have an initial condition that's negative, guess which of these two options we have to pick? The negative one. Our sign, S-I-G-N, of our function needs to match up with your initial condition, which is -2, -2. When x is -2, y is also -2. So if we want to state the domain as it says, right, it says to state the domain for our square root function, 4x squared minus 12 must be positive or, right, non-negative. That's the domain of any square root. We cannot take the square root of a negative, so everything underneath our radical must be positive or 0. So x has to be greater than or equal to the square root of 3. Which is probably going to be the square root of -3. Okay, let's look at a word problem. Sorry, not a story problem maybe. These are nice stories about wolves. This story is about wolves. Okay, and it tells us that the population of wolves grows proportional. So whenever we think proportional, you need to think differential equations. Y equals k times x, right? Proportional means that as x increases, y will increase also at this proportionality rate of k, which we don't know just yet. Okay? So we have this function, 750 minus n of t, where n of t is the number of wolves that are in the park for any given year. Okay, so y equals k times 750 minus n. Well, actually over here, we'll make this what it actually is. This is the number of wolves, right? This is the rate dn dt. And if we keep reading, we can see that this k value is going to be 1/3. That's nice. They tell us exactly what that is. We don't have to find that. Right? There's a lot of work that goes into finding that. And where y of n is a solution to the differential equation with the initial condition that there are 150 wolves in the park when we start counting. At year 0, there are 150 wolves in the park. Part A says find dn d squared n over dt. This is the second derivative. Okay, so you need to recognize this notation as being the second derivative. And the second derivative tells us about the concavity. If we have a positive value, then it's concave up. And if we have a negative value, it's concave down. So let's take the derivative of this equation. 1/3 of 750 minus n. Okay? So the second derivative with respect to time is going to be, well, let's distribute. What's 1/3 of 750? Well, that's 250 minus 1/3 of n. So what's the second derivative? What's the derivative of 250 minus 1/3 of n? Hopefully you know that's just negative 1/3. This is your variable. N is your variable. The derivative of a constant is 0. So the coefficient of n is negative 1/3. So is this graph concave up or concave down? Concave down. Because d2n over dt2 is less than 0. Okay? So our rate of the wolf population is growing, but just at a slower rate, right? So we're not getting as many wolves as fast as we were before. The wolf population is still increasing, just not increasing as fast. Okay, so part B says find that equation with the initial condition of 150 wolves at 0. So we're going to come back up to here, and we're going to solve this differential equation for n. Okay? So we're going to separate our variables. We're going to bring the t to this side, right? 1/3 of t, and we're going to divide by 750 minus n. Okay, separate our variables. So we have dn over 750 minus n equals 1/3 of dt. So let's take the antiderivatives. Okay, 750 minus n. This is a linear equation. This is a natural log, 750 minus n, antiderivative. But what is the coefficient of n? -1, which means we have a negative natural log out there. Okay, that's very important to remember that it's a negative. Okay, if we have 750 minus n, or 3 minus y, if our linear here has a negative coefficient, then the antiderivative must also be negative. Okay, so we knew that there were 750, t of 0 equals 250 wolves? 150 wolves. Yes, you are mi siento. 150 wolves. Wolves?
No, rolls.
Oh, rolls? Wolves. 150 animals. So that goes in here, minus 150. And t is 0. So our final answer for C is going to be the negative natural log of 600. So then we go back into here and we replace C with that value that we just found. Okay, our next step is going to be to get rid of this negative 1. So that means we're going to change the signs of all of our things. Right? When we multiply or divide by negative 1, all the signs change. So now we have a positive natural log, but at negative 1/3 t and a plus natural log of 600. So now we can exponentiate both sides. Okay, and of course the e and the natural log cancel out. 750 minus n equals e to the negative 1/3 t times e to the natural log of 600. So here, right, this becomes a 600 e to the negative 1/3 t. And let's add n to this side and then subtract. So our final answer is going to be 750 minus 600e to the negative 1/3 t. And that's our equation to find the number of wolves in the park at any time after 250 or 150. Okay, that's some good calculus. Great job.